Hello, and welcome to Ubuntu AI podcast. I'm Andrea, and together with Maciej, we will be your hosts. From fun experiments to enterprise projects, AI became the center of attention when it comes to innovation, digital transformation, and optimization.
Open source technologies democratized access to state-of-the-art machine learning tools and open doors for everyone ready to embark on their AI journey. Ubuntu AI will be your guide in the industry where a community of like-minded people meet to make an impact.
Maciej, thank you for joining me. Today, I think we'll talk a topic that you are the expert in. First of all, congrats for your keynote at Kubecon.
Thank you.
Now, let's dive into the topic. Why GPU utilization? How did you come up with this as a topic? And for those who maybe are not familiar or would like to look for your talk, you're talking about how to increase GPU utilization on Kubenetes clusters dedicated to machine learning workloads. And today I'm going to ask Maciej a lot of things about it. Why did you choose this topic, first of all?
Well, out of pure laziness, because this is the most common question that I got last year from people who are building their Kubernetes clusters for ML workloads or already have a cluster and have a problem with that because they have a low utilization and they don't seem to know how to increase it. So I was in these conversations over and over and over again and designed a lot of solutions for the end users, which were super similar to each other. So I thought that might be a good idea to make a talk about it, make a reference architecture, and give it for everyone to reuse.
But when it comes to GPU utilization, what do you think that this powerful hardware is underutilized? Is it because of lack of knowledge, lack of tools?
The general complex scenario. So first of all, I would start from the fact that you don't always need those GPUs, and that's why they might be underutilized, because obviously you can do your training and your inference on a CPU-based compute or on a GPU-based compute. And it really depends on what you are doing, because GPUs are obviously great in the matrix multiplication operations. But if you have small amount of requests per second, or you do some real-time inference for algorithms that don't really parallelize nicely, or you run on an edge device, it might be a better off using a CPU. And the problem is that people who are building the infrastructure for a bigger company, like to utilize across multiple teams, are usually not the same people who are training the models or building the product. And without them talking to each other in the beginning and clearly defining of what are the requirements, there might be a lot of mismatch. And it's also super hard because the whole industry is changing very fast. So it's not really possible to, let's agree in January what kind of compute we need. And this will be exactly the compute we will need in December.
So I understand that there are some challenges when it comes to agreeing and basically defining the GPU, but what are the scenarios when you should, or maybe our listeners should consider CPU-based training and inference, first of all, because that was one of the suggestions that you had initially?
Well, there are a lot of places where you can use both, and you could use CPU-based inference and GPU-based inference. Obviously, GPUs are much more expensive, so it's rather a cost factor, not the fact that it will not work, because you can run almost anything on a GPU, but sometimes it doesn't make economical sense. So that's what I'm more looking into. And also, if you have a GPU, and we are now going to one of the bigger problems that people have, let's assume that you have A100s or H100s, like proper big enterprise grade GPUs from NVIDIA. They have 40 gigabytes of memory. If you get a GPU allocated from your infrastructure provider, from your DevOps team or whoever, and your model training requires only 1 gig of memory and the GPU is fully allocated to you, the utilization is not great, right?
Do you think that this is one of the reasons why often projects get delayed and they seem not getting any return on investment?
Yes, because first of all, if everyone requests a full A100 GPU and you have 100 of them and 200 requests, you need to now discuss with everyone and prioritize who gets an access and so on. And they might actually fit on that infrastructure if you share them, but they will not fit if you want to give a full GPU to each and every person. So that delays a lot of projects. And ROI, obviously the GPU both on the public cloud and if you buy it and host on the private cloud, it's still pretty expensive. So if your utilization is 5 or 10 or 20%, it will be much harder to get an ROI of your AI project on a level that will satisfy your business stakeholders.
What does Kate has to do here, Maciej? How do you use Kate in these kind of scenarios?
Yeah, and that's a very interesting question because in the earlier days, the most popular thing to do if you had a big infrastructure and you wanted to run multiple processes and share them were a lot of things around high performance computing, HPC type of things like Slurm as a scheduler and so on. So this was how this was done and how it's also successfully done now in some places. But with the introduction of Kubernetes, we got much better tools on how to work and integrate with GPUs because we can now obviously share infrastructure in a standard context outside of machine learning with Kubernetes very efficiently. We have tons of tooling, a lot of processes, DevOps automation, everything to run normal workloads efficiently on Kubernetes. And if your GPUs are coming from a vendor that also invested heavily in Kubernetes, like NVIDIA will be a good example, you will have proper tooling from them on how to make Kubernetes also aware of that type of hardware. So NVIDIA GPU operator, for example, which is so-called one single component, but in reality, it has a lot of things in it, which are giving you that capabilities because you have normal Kubernetes device plugin that allows your Kubernetes to see the hardware. That's easy. But it also gives you a GPU feature discovery, which automatically sees what GPUs are in the nodes underneath Kubernetes and stack them accordingly. So like, okay, this is A100, this is A30, this is H100. So you know that your worker nodes have this particular GPUs in it. They are tagged, so you can use normal Kubernetes mechanism like taints and tolerations to say, okay, this workload goes into that box, this workload goes into other box. That's already efficient. But what you also have as part of the GPU operator is MIG manager, and MIG basically allows you to partition the GPU. So slice it into smaller pieces and give one GPU to 7 people, everyone gets a piece. And this is all baked into the GPU operator. So that's like a first low scale thing that Kubernetes helps you with. It will discover your GPUs, it will manage them. And if you have multiple types of GPUs, which I always recommend if you are building a big infrastructure, because some of them are better in one thing and some of them are better in the other thing. It does not make sense to have exactly the same GPUs all across your estate if you have multiple different workloads. And this is like the local thing. It gets even more exciting if you have multiple Kubernetes clusters or a lot of nodes connected to a network, and we can dive into that later on as well.
Before we get to that, Maciej, what's the tool that you can use to get your scheduler, your workload scheduled? And is it open source?
Yeah, so basically Kubernetes and all the tooling that I've mentioned that we will be mentioning today is open source because obviously we are coming from the open source world and that's what we prefer to use. But also there are commercial capabilities as well that you can find, but the open source tools are very good in that space and super popular. And I think that they have majority of the market share. So obviously when you are scheduling workloads, there are 2 levels of it. First of all, you need an application like Airflow or Kubeflow or a place where you define your processes and what kind of jobs you want to run. And also you need a scheduler in the Kubernetes. So Kubernetes is coming with a default scheduler, which works with the GPU operator, and you can already do some nice tweaks on it. If you have a lot of users, a lot of groups, and you want to do more sophisticated scheduling, like gang scheduling and things like that, you can add to your Kubernetes cluster Volcano, which will basically swap the default scheduler and use that if that's what you need. And with that type of projects, you can start scheduling your jobs efficiently.
Then why do you also need Paddle? I was just reading your abstract and I'm trying to depict it to get the full story.
Okay, so basically Paddle is again something on another level. So you have your scheduler, like Case Scheduler and Volcano. You have your level of like running your jobs with either Airflow or Kubeflow and so on. And Paddle is basically a framework that allows you to nicely parallelize operations. And it's especially important when you want to utilize multiple GPUs or utilize mixed slices efficiently. Paddle works with both a CPU and the GPU, by the way. So it's not like it's exclusive for GPU based infrastructure, but it's really good there. It's open source and it basically allows you to, even if you have like a single training job, which you would normally put in one pod and schedule on one piece of machinery, it can actually very nicely distribute and parallelize that training so that you have more pieces to work with. So if you have atomic pieces of the process that you want to run and atomic pieces of the infrastructure, you can better mix and match those in order to increase utilization.
I'm curious of something, and I'm not sure if you have the information because I didn't ask before, but do you know how the percentage of utilization that you could get improved by using this kind of tools or this kind of practices?
Well, how much you get improved, it depends on your starting point. So I've seen places very varying in that. The worst cases that I've seen in big infrastructures where people having 10 or 15% of base utilization. A standard case of a typical company that we are helping and we are starting to talk with is 40-50. And properly configured scheduling and resource management and like really advanced things that we will manage to achieve in some places were around 90. So depending on where you start from, you can get more or less of that.
Do you think that this will be a problem that will persist for companies, or you think it's something that, as the market matures, there will be more mechanisms to do it almost out of the box?
No, I think this will be a persistent problem because of the speed of development, because we are getting new and new technologies introduced into the mix, both on the GPU side. Also, other GPU vendors are getting into the picture, so it will get even more complicated when you want to schedule jobs on a cluster of half NVIDIA, half AMD GPUs. That's unsolved completely. And this will get more and more complicated with more vendors. Also, even what people are doing in terms of networking between the GPUs, like InfiniBand was the big name and big thing last 3 years. Now we have Spectrum X, which is much better, but how this will impact the scheduling, how this will impact GPU sharing. So this is like an ever-changing landscape. So I think that it will still be a problem. And why it will be important is, first of all, not only the cost, but also the sustainability of things, because GPUs require a lot of power, like a lot of electricity to run. So if you run them underutilized, that's again a sustainability and energy efficiency problem.
Do you see it feasible to have companies sharing GPUs between them rather than just one company having its own data center with GPUs to train? Because I assume there are a lot of organizations that they don't need that many GPUs, or they have moments when not they don't utilize them almost at all.
Well, companies sharing GPUs and infrastructure is something that already exists and it's very popular. It's called a public cloud. That would be the most popular way how people are doing that. But obviously, I know that your question is coming from like sharing the on-prem infrastructure of the companies, and that is more like a legal and business problem. I'm not so well versed in it if you can actually do it, depending on the regulations from country to country and that kind of stuff. So I think that technically it's easy and possible, but I don't see this happening anytime soon because of bureaucratic and legal concerns, not like technology limitation.
Fair enough. Yeah, and I didn't have in mind the public clouds. You're right here. Since you also, Maciej, brought up the networking topic, would you mind sharing with us the main differences between InfiniBand and Spectrum X?
Yeah, sure. But let's maybe start from why even networking is interesting and important for like machine learning. Because
Once in my life, no, Maciej, once in my life, I jumped the gun to questions and you took the step back. Go for it.
see, I'm learning. So basically, whenever you have a GPUs in one box or in one chassis of a server, then they can collaborate together. There are different ways of how to connect them efficiently. But there is a limit of how many GPUs you can put in one box. Typically, it's 2 or 4, depending on the type of server you have. There are some like big compute servers which might have 10. But if your infrastructure is 100 GPUs, obviously they will not fit into one server box. So what needs to happen is that if you want to pull those GPUs together into any shape, size, or form, either like run model training on 20 or 50 GPUs because that's what you need to make them talking to each other. And obviously they need to talk over the network because they are not in one box. They might not even be in one rack cabinet. They might not be in one room because there are some big server rooms with couple of floors, or they might be in a different building next to each other. So in order to make it happen, you need proper and fast networking. But the trick is how to do it, because what you need to do is to make sure that the memory, like RAM memory on one GPU and on another GPU, are connected. In the older days, we had RDMA, and that's basically remote direct memory access. So that was fine. And if you want to do it, you can do it over Ethernet, like standard Ethernet networking. It's called RoCE, RDMA over Converged Ethernet. And that was like the technology that was there, but it was super limited because it was limited by the speed of networking. Like if you have 10 gig network cards talking to each other and GPU memory speed is 20 or 200 times that, this will be a huge bottleneck. They will not work efficiently, and it doesn't make even sense to pull them because you will slow down the process, never train your model. So NVIDIA has their own technology called InfiniBand, which basically utilizes Mellanox network cards, utilize specialized switches, and has its own protocol with InfiniBand verbs that allow you to very efficiently make GPUs talking to each other over the network. The problem is that this is a proprietary solution. It requires specialized switches. If your infrastructure is not big GPU cluster only, it has other things. You need to have either separate networking for your GPUs, like it increases complexity and cost. So what NVIDIA did recently, they created a thing called Spectrum X, which is a new approach to the AI networking. It's fully Ethernet based, but it has all the capabilities of InfiniBand. So now you can use any switch you want, assuming that is fast enough. And you can still get the benefits of interconnected and internetwork GPUs. So that's awesome. And then we can start running our training jobs across multiple Kubernetes clusters connected with network to each other, and then actually get into the position of when like X or previous Twitter announces, okay, we are buying 10,000 GPUs training Grok. That's now possible thanks to those technologies.
Okay, I think that's interesting. And I mean, while I was listening to it, I did realize that maybe we should have a dedicated episode on networking for machine learning and what's the role that it plays. Because by far none of us is really a networking expert, I would say. Even if I see you're upscaling quickly, Maciej. If there is a new techie thing, you're gonna know about it. So basically, what you are talking or approaching in your keynote is really scheduling and resource optimization across different layers of the architecture. One thing that you didn't mention at all is Armada. Did you forget about it?
No, we didn't go to that big of a scale yet. So Armada is basically an open source project that allows you to efficiently schedule things across multiple Kubernetes clusters. So if you start growing your estate, because obviously if you have, I don't know, 5,000 nodes of compute, you will not put all of them into one Kubernetes cluster because your scheduler, your CRDs and your etcd and everything that you have in your case cluster will not efficiently scale to those sizes. So what people are doing, they are building a lot of smaller Kubernetes clusters. And obviously that could stay like this. You can have 1,000 nodes split into 100 nodes clusters, 10 of them, do it as a silo and say, okay, marketing team, your AI stuff runs on cluster A, sales team, your AI stuff runs on a cluster B, and you are good to go. Share the resources on both of those clusters or 10 of them, and everything is fine. But if there is a team that works over the weekend and the other team goes home because of different type of job or time zone limitations or the way how the work is done, the cluster might be completely unused for 2 days. or depending on like you have two teams in different time zones, one cluster might be not used in the night because they don't schedule jobs that they want to see them running. So in order to make it more efficient, what you can do is allow a team that typically utilizes the cluster A to schedule jobs on a cluster B, C, or D. And then Armada goes into a picture because it basically it's a component that allows you to run your jobs into like 5 Kubernetes clusters and efficiently manage that.
Just to ensure I get it correctly, I don't think companies who are not very, very advanced in the machine learning journey should look at Armada unless they over-provisioned and bought a gazillion GPUs.
I don't think it's even about the advancement in the machine learning. It's rather the size of your infrastructure. So if your infrastructure is in one place, in one data center, and you do one thing, yeah, it probably doesn't make sense. But a lot of companies that are even just starting in machine learning, if they are big global companies with operations across 20 countries, there is a data center in each of those countries. So being able to connect that and pull it on the like a group of resources that everyone can use, depending obviously on priority and time and everything that is necessary, that and schedule this batch jobs in a way that makes sense. That's super important. And I think that this can give a lot of benefits even to people starting with machine learning if they are starting from a point of having a big infrastructure available to them. And by big, I mean located in multiple places.
I know this podcast is not on video, but why would you start with machine learning with a big infrastructure when you're just getting started? That's against my belief.
Well, it's not like that you are starting as a person or as a single project with a big infrastructure. But we had customers who are big banks with operations in 20 countries. And in every of those countries, there is 1, 2, or 3 teams which have a great idea and a great project that they want to run. So then you have 50, 60, or 80 teams actually starting in parallel, not even knowing about each other and trying to do things. It's more efficient if you let them share their resources, but also share their findings, put them on the same MLOps platform like Kubeflow, where they can all see each other's notebooks, each other runs, maybe get some benefit of the data cleaning that other team did, and so on. So you're basically encouraging collaboration across a big company, not giving one person in that big company the entire estate.
Okay, fair enough. We are getting close to an end, Maciej. I'm trying to recap what are the main key learnings here. And so on one hand, taking it backwards, putting all the resources in one kind of cluster that can be utilized is one learning and one key topic that you'll approach during your keynote, but also optimizing the resource utilization as well by scheduling the jobs will be one of the second key points or learnings that I guess your keynote will have, probably more practical things. Then you will also cover a bit about or around networking as well, and how that impacts the GPU utilization. And last but not least, you will approach the distribution of the training jobs by using Paddle. Is there anything that I missed?
So the one more thing that I will be adding on top of that is make sure that this is a living thing that can actually operate after you build it, which basically means observability. Because what you need to be able to do is to see that, okay, the cluster is now split in this ways, that type of GPUs, that type of jobs, priorities, teams, gang scheduling. That's fine for today. But if you don't have a granular observability and you are not able to see how the cluster is utilized, you might have 95% of utilization now, and in a few months you will go down to 50 and you will not know what happens. So the observability of all of this is also a super important aspect. And last but not least, the glue that holds all of this together. And the glue that holds all of this together is open source, because you can build this type of infrastructure on all the layers of the stack, starting from the box itself, the operating system, the GPU drivers, then Kubernetes clusters, schedulers, tools to run multiple jobs on like Airflow and Kubeflow, having Armada to do batch jobs, like all of these layers of the stack are all open source projects with communities that are collaborating with each other and optimized all the way from top to bottom. And this is the actual benefit that you get from diving into the open source space on the infrastructure side.
Okay. I think it makes sense. Fair enough. And I think next year you can come to us and talk on how do you integrate AMD and NVIDIA GPUs together in a cluster.
Yeah, I'll try to figure it. I will try to figure it out.
That sounds like a plan. You know me, I always ask for a thought of the AI of tomorrow. What's your thoughts today?
Well, that's easy. If you can go to Kubecon, if not watch the video transmission, because what I've seen at the lineup, there are tons of super interesting talks that I want to see, and I think that a lot of our listeners will benefit from that as well. There is a separate track on Kubecon as well dedicated for AI/ML, which is a great thing to watch. There is also a Kubeflow Summit co-located together. So if you are interested in like open source tools for MLOps, that's also a great thing to watch. There are a lot of talks there, which seem interesting.
Well, I also have to say that you can find Maciej and one of our other colleagues, Kimonas, I think, at KubeCon, so you can just go and ask them all the questions you want. Maciej, for you as well, maybe we get another podcast from KubeCon with some of the great speakers that we have there. I will not.
Yeah, for sure. I will try to catch some people to talk with them because there are a lot of big and interesting names from the industry that I wanted to interview, and to also probably make some video around the floors and see what's like latest and greatest new tech that seemed exciting for us, especially from AI/ML angle, and how you can use Kubernetes to help your efforts in that space.
Don't give me fear of missing out. I'll be at GTC and do the same. Let's see who has more fun and learns more. On my side, I think the thought for the AI of tomorrow is really to use wisely the resources that you have. Don't just think that the success of your project is defined by how many GPUs you have or how much compute power you have, because there are obviously alternatives. There are obviously ways to optimize the way that you use your resources. And Maciej touched a bit upon it, but there is also a sustainable angle that I think we should responsibly keep in mind whenever we just add compute power without having a clear picture on how much we already use out of it. And I think with this, I'm going to wrap it up. Thank you for your time, everyone. Thank you, Maciej, for joining me once again. This was Ubuntu AI, and your AI journey stops here for now. We'll meet again in 2 weeks with a new episode. In the meantime, if you liked this podcast, feel free to follow us, share it, and subscribe. And you can also follow more articles from us on Medium. See you soon.
Thank you. See you at KubeCon.